Okay, so this is my task 5 major project for Sense Tech, and this is the documentation of my code used and the processes behind my gauntlet that I created for sound manipulation within Max/Arduino. So, as you can see here, this is my background code. This is the serial port manipulation process hosted within the Arduino IDE. Again, it's taken from the simple serial, pretty similar to my other task, which utilises serial ports into Max, except for this time it's taking just 4 inputs, analog ones, which are then being transferred to the serial port. So as you can see here, just some constant integers set up here, which is obviously for the thumb, index, middle and pinky finger. These are the respective analog inputs as well. They each have their own LDR set up on each finger, which explain the logbook. This is then obviously just printed to the serial port. It's nothing very complex. It's just transferring the data straight from the gauntlet straight into my Max project. So moving across to Max, you can see here this is the presentation view of my patch I developed for the synth manipulation. And essentially what it is just a saw versus cycle oscillator. So what it does, if I just explode it out, is take some data in from the serial port and use that to manipulate 2 signals, which are then put into a mixer together. So as you can see here, this is obviously familiar. This is the same translation patch that I developed for my other Arduino to Max task, except this all of the other translation data which I had has been removed. That was more for the step sequencer and just making sure everything was in sync, whereas obviously because here the delay time between steps coming out of the Arduino IDE is a lot narrower. I wouldn't have to worry as much about sort of spikes in data or inaccuracies, because obviously there's a constant flow, so these integers are constantly being updated. So obviously you've got the same process here. Obviously the information gets unpacked from the serial port and is labelled here as a respectable finger. So obviously gain is controlled by the pinky finger. Modulation intensity for these both of the cycle and the saw objects is controlled via the middle finger. The index finger controls the frequency of the modulation, and the carrier frequency, obviously the frequency of both tones, is controlled with the thumb. I chose each finger respectively. So the pinky finger was chosen mainly because it's so far away from the light source in the center, and drastic movements, so the bigger finger, obviously a bigger turning moment, would create obviously a larger amount of gain loss and increase, whereas the pinky's further away and it allows me more accurate manipulation of both the sine and sawtooth. Obviously they're both controlled at the same time. So modulation intensity and modulation frequency are both on the index and middle fingers, mainly because they're the main 2 parts of the project that I want to manipulate. These are the main 2 prominent parts of it. Carrier frequency, again, is the thumb. I find to be more kind of articulated. It allows me to kind of change the pitch slightly rather than having big sort of swooping frequency changes up and down, up and down. So obviously it's quite a bit messy, but the scale objects I've used is just these are highly modifiable. If someone else were to use it, I'm sure they'd probably change it themselves. This is what I felt comfortable with. See, scale, this is just the standard analog input range for the LDRs, and I've got 170 to 3000 for the modulation intensity, because I just wanted that really dramatic range. But then for things like modulation frequency, when it gets too high, it starts to sound a little bit distorted, so I decided just to have that scaled at a slightly lower range. The same goes for carrier frequency, mainly because I didn't really want the pitch being really, really high or really, really low, where it's like just turns into a sort of rhythmic thing. The gain, again, is scaled to minus, because I didn't want any increase in volume apart from the maximum, because it starts clipping things out. So you can see minus 20 and 0, minus 20 decibels doesn't actually sound that different when you've got 2 really big oscillators playing at the same time. And as you can see here, the cycle and saw objects are manipulated by this process here, which basically just allows me to change properties of the oscillators and apply modulation to them independently, and then they're both routed down here and into their respective mixers. You get this really nice sort of lovely warm conflict of frequencies, and you get this really nice phasing sounds and just really crazy noises, which is why I enjoy doing this one so much. And if you watch the next video, I shall provide a demonstration of it.